Hi viewers, welcome back to the second segment of the, welcome to the second segment of the fourth lecture. So we've been discussing about the relationship of path equivalences with commutative diagrams by means of a given Olog. Now, a natural question to follow is if we can have a non-commuting diagram. Okay, so can we have a diagram which does not commute? Okay, let me give you an example. So an example of a non-commuting diagram. An example of a non-commuting diagram. Non-commuting diagram. A person has as father a man. It makes sense, right? And a man lives in a city, say. A city. And a person also lives in a city. Alright? In order to make this diagram commute, a person has to live in the same city as his father does, as his or her father does. But it is not the fact, as we know. Okay? A person can live in a different city than his or her father. Okay? So the non-commutativity of the diagram presented in the figure above, dictates that every person dictates that it is not the case that every person lives in the same city, lives in the same city as his or her father. Okay? So let me underline this fact. Alright? So a person may live in a different city than his or her father. That's okay. So there is a small warning here that I want to note down. Okay? A small warning. Okay? The non-commutativity of the diagram here, of the diagram that we are considering does not state that no person lives in the same city as his or her father does. Okay? It does not tell you that no person lives in the same city as his or father does. Okay? It means that there may be a person which lives in the same city as his or her father does. Okay? Alright. So this is not correct. Non-commutativity of the diagram does not tell you this thing. Okay. So now we need a notion of the length of a path. Alright? So let me define the length of a path for an Olog. We need it for defining facts often related to an Olog. So what is the length of a path? So we'll capture the definition from an example of an Olog. So we're discussing length of a path. Length of the path. Alright? So let me give you the example. Consider the following Olog. Consider the following Olog. A child is a person is of course a functional relationship. I mean that it upholds a functional relationship. It's not exactly a functional relationship because they are not sets. So that discuss these things in detail using instance function. And from a person goes another aspect. Has a parents. Up here. W, N, where W is a woman, and M is a man, and from which it's a projection to the first entry, which is precisely a woman. This is one path, right? So consider another path has as birthday a date and from a date via includes to a year. This is another part. Alright? So we'll say that. So we'll count the arrows in each path and we'll see that there are 3 arrows in the first path and also there are 3 arrows in the second path. So we said that both the paths have the same length, okay, which is 3. So how do we read the first path? We read the first path as a child is a person who has as parents a pair W comma M, where W is a woman and M is a man, which yields a woman. This is how we read the first fact. Let me do it again. A child is a person who has as parents a pair W comma M, where W is a woman and M is a man, which yields via the value of W a woman. Okay? So I think I missed this value thing in the beginning. So it should be read as, this part should be read as, which yields via the value of W a woman. Okay, and how do we read the bottom part? The bottom part should be read as, a child is a person who has as birthday a date which includes a year. Okay. Again, a child is a person who has as birthday a date which includes a year. This is how you read the second part. Now let's get back to facts. Okay, now we know what it means by length of the path. We get back to facts. We discussed how to write a formula for writing facts in English. A formula for writing facts in English. Okay? Okay. So here are some facts associated with the fact. Okay? Some facts associated with the fact. Okay? Every fact consists of two paths say P and Q, say P and Q, that are to be declared equivalent. That are to be declared equivalent. So once we do that, when we declare two paths to be equivalent, we call that a fact. Okay? So there should always, in order to have a fact, we should have two paths, say P and Q, and we want to declare them to be equivalent, and that's precisely the fact. Okay. Okay. And another fact associated with fact is that the paths P and Q will necessarily have the same source network. Okay. The paths P and Q will necessarily have the same source. Same source, say S, and target P, and target T. But their lengths may be different. But their lengths may be different. Their lengths may be different. but they should have the same source and the target. Okay? Say, I mean that the lengths here, say m and n respectively. M and n respectively. Okay, let me draw it in terms of the picture. We draw these paths as we draw these paths as, okay, so we denote the first path with P. Okay, so the source being up, A0, represented as this with this dot. And an aspect going to another dot A1 and going to another dot. The dots represent the types of the Olog, okay, and these F1, F2, these represent the aspects. From A2, we have another arrow denoted by F3, all the way up to Fm minus 1, pointed to En minus 1, and from En minus 1 via Fm to Am, which is the target. Alright. And the second path, alright, starts with the same, so I should write this A0 as S, which is the source, underlying source. And then we have for path Q, B0 the starting point, which is the same source as S. Okay. From which we have an arrow hitting B1, and from B1 to B2 via arrow G2, and from B2 to another tie B3, say, we're not writing it, all the way up to Bn minus 1 via the aspect Gn minus 1, and from Bn minus 1 to the target Bn via the aspect Gn, and Bn must be equal to P, meaning that these two terminal objects should be the same and the initial objects should be the same. But the paths, the length of the paths may be different. For the first path, the length is n, and for the second path, the length is n. Okay? So, in the last segment of today's lecture, we'll try to explain how we can convert these diagrammatic ideas into English sentence. Okay, so let me stop this segment now, and we'll get back to you. I'll get back to you with the last segment of lecture 4, where we'll discuss the rest of the materials to be covered in the lecture. Thank you.